Welcome to the Human Chronicles, where we explore the story of our world, our species, and the universe that shaped us. In this episode, we journey to the very beginning of our planet, tracing the formation of Earth from a cloud of cosmic dust to a dynamic world capable of supporting life. In the darkness of space, more than 4.6 billion years ago, a vast cloud of gas and dust drifted silently across what would become our solar system. This cloud, known as the solar nebula, contained all the raw materials that would one day form the Sun, Earth, and every planet, asteroid, and moon in orbit around them. Gravity, the invisible sculptor, began its work. Tiny dust grains collided, sticking together in an endless, slow-motion dance. Pebbles became rocks, rocks became boulders. These boulders combined into kilometer-sized bodies called planetesimals. Each collision released heat, melting the growing bodies and causing them to differentiate, heavy metals sinking to the center, lighter silicates rising toward the surface. Over tens of millions of years, these planetesimals merged into planetary embryos. One of these embryos, a glowing, molten sphere, became the proto-Earth. At this stage, Earth was far from the calm blue planet we know today. Its surface was a turbulent ocean of molten rock, constantly reshaped by collisions and heat from radioactive decay. But Earth's formation was far from complete. Around 4.5 billion years ago, a massive object roughly the size of Mars, later called Theia, collided with the proto-Earth in a cataclysmic impact. The force of the collision was immense, enough to melt a significant portion of the planet and eject a vast amount of debris into orbit. Over thousands of years, this debris coalesced into a single body, the Moon. Theia's impact also tilted the Earth's rotational axis, setting the stage for the planet's seasons and stabilizing its long-term climate. Without this tilt, Earth might have spun chaotically, making stable seasons and climates impossible, a factor that would prove critical for the development of life billions of years later. In the aftermath of the collision, Earth's surface remained molten for millions of years. Meteorites from the leftover debris in the solar system continued to strike, adding heat and new materials. Volcanoes erupted constantly, spewing lava, ash, and gases into the early atmosphere. The first atmosphere consisted primarily of carbon dioxide, nitrogen, and water vapor, with little or no oxygen. As the planet gradually cooled, water vapor in the atmosphere began to condense into clouds. Rain fell for millions of years, slowly filling the low-lying basins and forming the first oceans. These early oceans were acidic and rich in minerals, providing the perfect environment for chemical reactions. Meanwhile, small, fragile landmasses emerged above the molten seas. These early continents were constantly reshaped by volcanic activity and tectonic movements, yet they provided the first stable surfaces where weathering could release minerals into the oceans, further enriching them and supporting complex chemical processes. Within these oceans, the building blocks of life began to form. Simple molecules interacted, creating increasingly complex organic compounds. Hydrogen, methane, ammonia, and water combined under the influence of heat and energy from lightning and ultraviolet radiation. Over millions of years, these reactions produced amino acids, nucleotides, and other prebiotic molecules, the essential ingredients for the first living cells. By the end of the Hadeanian, Earth had transformed dramatically. From a violent, molten sphere bombarded by meteorites, it had become a dynamic, evolving world. Oceans covered the planet's surface. Continents provided stable landmasses. The atmosphere, though hostile by modern standards, allowed water to persist. Earth's first solid crust had formed, a thin but resilient layer over the molten interior. Tectonic activity began shaping mountains, valleys, and volcanic systems. The balance between the crust, oceans, and atmosphere created a dynamic system, a planet ready to support the processes that would lead to life. This was the birth of Earth, a planet forged by fire, shaped by collisions, and molded by gravity. Every volcano, every ocean, and every emerging landmass set the foundation for a world capable of nurturing life. What began as a chaotic swirl of dust and rock would, over billions of years, become the home to complex organisms, ecosystems, and eventually, humanity itself. Thank you for joining us on this journey through the origins of our planet. If you found this exploration of Earth's earliest moments fascinating, be sure to like, subscribe, and return for more episodes from the Human Chronicles. In our next episode, we will dive into the first oceans and explore how the chemistry of early Earth set the stage for life itself.